Hello Techie guys, welcome back to Techie Uday. In our last video, we have seen what is the function and how the execution transfers from one function to other function when you call one function in other function. Right. In this video, we are going to see what actually the recursion means and how many types of recursion we have. As we are discussing in our previous videos as well, the recursive function is a function that is calling itself. The point to be noted here, the function might be same for us, but it's not the same function to the system. The moment you call a function, even it is the same function, the system treats it as a completely new method with the new parameters and with a new state. That is how the main concept of recursion evolved. What is a recursion? Recursion is a process in which a method calls itself to solve smaller instance of the problem. That is a definition. Basically, a method calling itself is termed as a recursion. In the recursion, we have two parts. One is the base case and one is the recursive case. Base case is what? Base case is like a terminal point. We need to say to the system, don't call this method again and again. It leads to the infinite calling and it leads to Stack Overflow. I already explained this in my previous video, how the Stack Overflow happens. If you do not watch that video, please go and watch that video before continuing further. So if you skip the base case, it leads to the infinite calling of the recursive method. So it is very important for any recursive function to have a base case. Let's see the example here. In our previous example here, I'm calling say hello and it went to Stack Overflow exception. Let's see that. When I call this method, see, so many recursive calls has happened and finally I got the Stack Overflow exception here. This is because we skipped the base case in this recursive function. It is calling itself indefinitely, so we got a Stack Overflow exception. So to avoid this, we need to have a condition. We need to specify when to stop this recursive process. I can specify like if equal to 10. If n equal to 10, return. Will this works? Because I am saying the function to stop when n becomes 10. Will this works? Let's see. No, it don't works because I am saying if n is equal to 10, stop the process. But when the n value becomes 10, it is 0. We are not even modifying the values. So it is very important to take care to meet that recursive or to meet the case where the recursive function stops. The system or the program won't automatically take care of it. So you need to take care to meet the condition or to modify the variables or to modify the conditions such that at particular point the recursive call stops. So at each and every call I am incrementing the n value by 1. Then what happens? This call executes only 10 times. Is it? Now it's again came to the Stack Overflow. You are changing the variable, right? But what's happening? Can you guess? You are changing the variable. But where you are changing the variable? After the recursive call. It never reaches this point. So you need to be very careful while giving this type of, even though you are modifying the variable, but syntactically it is correct, but logically you are changing the variable after the recursive call. But as I said earlier, the function always wait on this line to continue further. Since this is a recursive call, it never comes to this line to modify the variable. So it is very important to check the logic clearly whenever you're doing something. Let's see this. Right now I am here, it's 0 and recursive call happened 10 times. Now after that I am here, it is 10. Here say hello again called, but it never executed because n value is already 10, so it has no effect. And in our problem solving, we'll use this base case as a base solution for our problem and the recursive calling as to solve the problems that depends on the base case. It is say, for example, it is saying like Fibonacci of n, the function. In this function, the base here is the base case. This is the base case here, and this is the recursive case. Here we are using two cases. Like what is the Fibonacci series? It is like the sum of two previous numbers, isn't it? The sum of two previous numbers. If I take in the Fibonacci of 5, it is the sum of Fibonacci of 4 plus Fibonacci of 3, right? The sum of previous two sums. So what is the base case here? The 0 and 1 or the base case. In the Fibonacci series, the first two numbers are 1 and 1, and the other numbers adds up the two previous numbers. So this forms a recursive case like Fibonacci of n minus 1 plus Fibonacci of n minus 2. Fibonacci of 5, what actually happens? When I print the Fibonacci of 5, let's see what actually happens there. I'm debugging it. So I'm calling the main method here, it is, and I'm calling that Fibonacci of 5, n is then less than 1? No, right? N is 5. So it is 1 to Fibonacci of n minus 1. Now see here, a recursive case for n minus 1 has been called. It is calling this n minus 1 Fibonacci. It never comes to here. It is calling Fibonacci of n minus 1. N minus 1 is 4. So Fibonacci of 4. And again, and not less than 1. So n value is 3. Again, it go back. And 2 go back. Now n value is 1. So what happens? It returns. See here the recursion stack. This method is waiting on this line, but in this line it is waiting on this first recursive call. It never tried the second recursive call yet, because the execution starts here. It is waiting on the first recursive call of this. This is waiting. This method is waiting for this Fibonacci function to be executed, and this line is waiting for this to be executed. N is equal to 4, here n is equal to 3, here n is equal to 2. All these lines are related to this first function call. It's not even trying the second function call now. After the execution, like this has completed, now control came to the next line. You can see now after this function call, it calls the second function call. It is very confusing if you do not understand my previous video. So whenever the one function call is completed, then the control immediately execute from the very next line of the called function. Here the calling function and the called function both are same, so it will be a little confusing to understand, but with practice you can get to the point to understand this concept very easily. So this is how the recursion function works. So finally we got the answer of Fibonacci of 5. What is that answer? Fibonacci of 5. Finally we got the answer like Fibonacci of 5 is 5. It's like 1, 1, 1 plus 1, 1 plus 1, 2, 2 plus 1, 3, 3, 2 plus 3, 5. So the fifth number is 5. We got the answer. The Fibonacci of 5 is 5. So this is how the recursion function works. And how many types of recursions we have, we'll see that in the next video. Thank you for watching. Have a good day. Bye bye.